Now, before we start on the lesson, are there any questions over the homework that y'all have? Okay. Now, the first thing we have is this theorem here. You can write it down if you want, but for the most part, it makes sense. Because the square root of a negative number property, well, if r is a positive real number, then the square root of negative r is I times the square root of r. And that's what we did the other day when we were simplifying the square roots. We pulled the negative out as I, and then found the square root of whatever that number is. By this first property, it follows if we square it, we're going to get back to negative r. Yep, because square root of r squared is just going to be r, and when we square I, and again I squared is -1, so we get back to negative r. So it just makes, this just follows, it makes sense. And what we're going to look at first is actually solving some of these equations where we get these complex solutions, these complex numbers. So the first one we're looking at is this one here, x squared plus 4 is equal to 0. And what we'll be using is the square root method. And the reason we can use the square root method is because, well, the middle term, we don't have one. We don't have x to the first power. So we can get x squared by itself. And the first thing we can do is almost minus 4. Since it's plus 4, we would subtract 4 from both sides, telling us x squared is equal to -4. Then we square root both sides. Square root of x squared is x. Now, since we have a negative inside the square root, well, before we do that, we have the plus and minus. The negative would come out as I, and the square root of 4 is 2. So we get x is equal to plus or minus 2i. And realistically, this is saying that x is equal to 2i and x is equal to -2i. Now, one of the formulas we had yesterday was the complex conjugate theorem, and it stated if we have solutions for the following polynomial equation, and x is equal to a plus bi, then x is equal to a minus bi is a solution. Or if a plus bi is a solution, then a minus bi is a solution. Well, here we have bi, yes? So we also need, and that's all it was saying. If we have one, we have to have the other. They always come in pairs. And that's it with that there. So it's kind of going along the lines and saying this. If we know that x is equal to 4 minus 3i is a solution to the equation, it means that x is equal to 4 plus, not 4i. Almost. X is equal to 4 plus 3i also has to be a solution. If we have one, we have to have the other. And interestingly enough, we'll get to it eventually, but square roots, they have the same thing. Because if the square root of 2 is a solution, the square root, or negative square root of 2 has to be 1 also. So what can we do first for this one here? We can add 11 to both sides. Yes. And then what do we need to do next? We'd want to divide both sides by 2. We can't take the square root yet. I mean, we could, but then we'd have to divide both sides by the square root of 2 to get x by itself. And then take the square root of both sides, which tells us x is equal to, we'll say 3i square root of 2. Because we bring the I out for the negative, square root of 18 is 3 square root of 2. So we plug it in, and we get this here. Questions on any of this so far? And the last one of this first page is to find the zeros of this function. And we've done all these before, except this time we have complex. We have these solutions with I. Now, if I want to find the zeros, really I'm just saying we're trying to see what's going to make this equal 0. Yes. Which will tell us that negative 20 is equal to 4x squared. What would we do next? We would divide by 4, yes. Right, then we take the square root of both sides. Square root of x squared is x equals plus or minus. The negative would come out as square root of 5. And that's it. Now, one thing I will say on this here, and I didn't mention this earlier, when we look at these functions like this here, and we went through that whole part on transformations, moving it up, down, left, right, stretch, shrink, and doing all this here, well, we know on the normal function, x squared, the smallest value is 0, 0. That's where it meets the x-axis, and when we solve, we're wanting to see where it crosses the x-axis. Well, the 4x squared, 4 is just telling me it's a vertical stretch of 4. So it's going to make it skinnier. I don't need to know specifically how, but I know it's going to be skinnier. And the plus 20 tells me it's moving the whole function up 20, yes? So the normal function opens up, a little bit skinnier for this one, and we moved it up, yes? Is there any chance this is going to cross the x-axis? Well, no, because it's already opening up like this to begin with. And if we move the whole thing up 20, we moved it away from the graph, it's never going to cross. I don't have to know the exact way that function looks or the graph of it, but I know it's going to open up. We moved it way up. There's no chance it's going to cross. So I should have no real solution. Our solution should be complex. And that's what's nice about it. It's not that we have to know exactly how it works and what it is. It gives us an idea of what the graph should do, what the function should do, what kind of solutions I should have. If it had been negative, 4x squared, we know that it's going to flip it and go down. That means it should cross the x-axis. So we should have some solutions that might be nice numbers, like 4 and 12, or they could be irrational, where we get our square root of 3. But we will have a number without I, because it'll cross. And that's what the transformations are nice. It gives us an idea, a picture of what the graph will do. Doesn't mean we have to have a perfect picture, but it does give us an idea of where to start. Does that kind of make sense? Now, this one here, we're going to do a little different than we normally would. This is kind of leading into completing the square, our first kind of main method that will work for every single equation. Now, it's telling us using the square roots method, or using the square root method. Now, the square root method works if we have x squared but no middle term, or we have a set of parentheses squared, yes? Now, what we'll do first is we're going to factor this thing. X squared minus 16x plus 64. Yes, so we'd have our two sets of parentheses with 3 spaces. And yes, because the 64 is positive, our signs are the same and they match the sign of the middle term. X and X. Well, there's a good number of factors for 64, because we have 1 in 64, 2 in 32, 4 in 16. 5 doesn't work because it doesn't end in a 0 or 5. 6 doesn't work because for 6 to work, 2 and 3 have to be factors. 7 doesn't, but then we have 8 and 8. Mm-hmm. And if we checked it, these would work. But there's a reason we did pick 8 and 8. Because what do you notice about these two here? They're the same, yes? Whenever we have something times itself, I can rewrite it as 1 squared. Because x minus 8 times x minus 8 is the same as x minus 8 squared. Now, most of the times we want to rewrite it out as the 2 so we can work from there. But if I have it by itself, we can do what? I can square root both sides, yes? Because here the square root and square cancel, leaving us with x minus 8 is equal to plus or minus 10, yes. Now we need to solve, because we can now add 8 to both sides, telling us x is equal to 8 plus or minus 10. Now, on a lot of the problems that we've done, especially in class up to this point, this is where we left it. But also, instead of having 10, we had something like square root of 3. Or we had some irrational number, yes? But looking at this here, can I add 8 and 10? We can do 8 plus 10, yes? Can we do 8 minus 10? Yeah. If we can actually add them together without having to approximate, or we can actually subtract them without having to approximate the number, my brain is getting ahead, we're going to go on and find them. So here, 8 plus 10 is, and 8 minus 10 is, so x is equal to 18 comma negative 2. Because we can write it with a comma instead of having to list x is equal to 18, x is equal to negative 2 to list the answers. Now, if we had gotten something instead of this here, I'll get a different color. Something like x is equal to 8 plus or minus 10 square root of 3. We're going to leave it as this here. Because the square root of 3 is irrational, we would have to approximate to get our answer. So we can leave it as this here. Now, on the ACT or other tests, and if you take college algebra or above, and they ask you to approximate your answer to the nearest thousandth, we have to approximate. But to do that, it's really just saying, especially in the graphing calculator, if you type that in, hit enter, it'll give you the decimal. And then we can select it and change it to 8 minus. Hit it again, and it'll give us the answer. But for me, for these here, I would leave it as this here. If we can simplify it, go on and simplify it. Any other questions on this here? Now, this is nice, because if we can take part of the quadratic and rewrite it as a single set of parentheses squared, we can use the square root method and solve, yes? Now, there will be 2 of these on the homework tonight, where they already have it set up that the quadratic to start with is what we call a perfect square trinomial. It's one that we can rewrite as a set of parentheses squared. However, not every single one is. We've already done a lot, especially in 3.1, where both sets of parentheses weren't the same. But if we can get them to be the same, then we can use this here. And that's really at the core of what completing the square is. Now, there is a nice little deal with this here, that we can make any quadratic if we're given x squared and our term in front of x, our number with x. We can find a c value, a constant term, that will make it a perfect square trinomial. And really what we're saying is c is equal to b over 2 squared. For most, they just want to know, what do I need to do to solve it? But kind of that explanation that anybody that's watching the video doesn't get to see, that's kind of why this works, why c is equal to b over 2. And you'll see in a minute why it works even better when we start factoring. You've already seen it, so you know why it makes sense now. So for this here, again, we're connecting it with our ax squared plus bx plus c. That's where we get our b. And in this case, what is the value of b? B is 14. Now 14 divided by 2 is 7. And 7 squared is 49. So our perfect square trinomial is going to be x squared plus 14x plus 49. And that's what makes this nice, is now any quadratic I can turn into a perfect square trinomial. I can turn it into a form that we can make it into a set of parentheses squared. Now we need to see what that set of parentheses squared is. Now the first term is going to be x inside those parentheses. It's not always going to be x, because if instead of x squared plus 14x plus 49, we had y squared plus 14y plus 49, we wouldn't put x, we would put y. It just depends on what the variable is. Doesn't change anything, it just changes how it looks. Now we need to figure out what number goes in there with it. If we were doing the factoring, we would have our two sets of parentheses. Since the 49 is positive, the signs are the same and they match the sign of the middle term, which would be positive, yes? And yeah, it would be 7 and 7 because we want them to be the same. What's the number before we squared it? Positive 7, yes? So whatever the number is in there before we square it will be what goes inside the parentheses with the sign. So if it had been negative 7, inside the parentheses would have been negative 7. And that's it. Kind of makes sense on this here?
So we need a perfect square and the expression would be the x plus x squared.
So to rewrite the expression as a binomial squared is this here. Now the value of c that we want is the 49.
Yeah.
And sometimes it's, if you want, you can just do those two parts there, and that would be your answer. Yeah, because, and this c value will always be positive, because whenever we square a number, we get a positive. Now, I reiterated myself, but the reason that's a great point. That's a great thing to think about. In this whole part, the fact that squaring number is going to become positive is the whole reason we have I. Because I, again, is square root -1, coming down to the whole point of what number times itself gives us a negative, which never happens. So again, this value of c is always going to be positive. And it's even going back to our factoring. When the third term is positive, the signs are the same and they match the sign of the middle term. Because again, for us to get c, we're taking two numbers and multiplying them together. The only way we can get a positive is if their signs are the same. The fact that a negative times a negative is a positive, or a positive and a positive is a positive. Things start making even more sense. Yeah, but that's, again, one of the beauties of why this works the way it does. Any other questions on this one here? So, the value b here is 8. Now, again, we could have typed this in the calculator, bless you. We could do parentheses 8 divided by 2, close parentheses squared, and it would give us our answer. But the reason I don't normally do that is because here 8 divided by 2 is 4, yes? So that tells me that this is going to factor to what? X plus 4 squared. Yep, because if we skip that middle step, we have to go back and try to figure out what is going to go inside the parentheses. Now, luckily for us, dividing by 2, cutting it in half is not that bad. Because we can cut most numbers in half, and if it doesn't work out, well, we can see number 6 is not going to divide by 2. We can leave it as a fraction. We don't have to cut it in half if we don't have to. But here it does, and 4 squared is. That tells us that x squared plus 8x plus 16. And that's it. Now, for each one of these here, and especially on the homework, you don't have to write the b over 2, because you could do c is equal to, for this case, is negative 2 over 2 squared. You can go on and just write that down and work it out from there. Well, negative 2 divided by 2 is, which tells us that we have x squared minus 2x plus, inside our parentheses, we're going to have x minus 1 squared. We ready for the last one? So c is equal to, so b over 2. So our negative 9 over 2, because we take the sign with it. Does 9 divide by 2 evenly? No. We're going to leave it as a fraction. So we have that, yeah, so this would be x minus 9 over 2 squared. Now, squaring this is actually not as bad as it seems, because we can square each part. But we know it's going to be positive. So 9 squared, 9 times 9 is 81. Yeah, that's not too bad. 2 squared is 4. Yeah. And memorizing all your perfect squares is not necessary or an important thing anymore. Because I just recently have gotten 14 squared memorized. Because 13 squared is 169. 14 squared is 196. So it's just flipping those last two. So any questions on this here? And I can go back over this here in a minute.
Would that be it for number 6?
Yeah. We just have those two there. And the reason, part of the reason we leave it as a fraction is because when we start solving these, we're going to have to take the square root of the other side, and it's hard to take the square root of a decimal. It's easier to take the square root of a fraction. Now, let's see here. Okay. These here are the main steps in solving an equation by completing the square. If we're going to solve an equation by completing the square, these are the main steps that we have. The first step is a equal to 1. If not, we're going to make it so. So if it was at 2x squared, we have to divide everything by 2. Get all the constant terms away from the variables and leave 2 spaces. Get the constant terms by itself. Then we want to find the value of c. c is equal to b over 2 squared. And then find the perfect square trinomial. That's what we did with that. Essentially factor it into one set of parentheses squared and solve. Now, again, I know you didn't write those steps down. You can follow along with this if you want. But again, I just want to show y'all so that you've seen one. This isn't on the homework. But I want y'all to at least seen one way of this being done, because what we're doing tomorrow is actually delving into doing these and solving these by completing the square. And the first thing we can do with this here is get this constant term over the other side. Now the first step is a equal to 1. Well, yes, the number in front of x squared is 1, so we're good there. So we need to get the constant term to the other side. And leave 2 spaces. Because again, we want this to be a perfect square trinomial. We're going to find that value of c to plug it back in. c is equal to b over 2 squared. Almost, it is negative 10. Negative 10 divided by 2 is negative 5. And negative 5 squared is 25. Now, the reason we need to go all the way to this here, because we could have just found out what b over 2 squared is and did our parentheses squared. But what I'm doing is I'm adding the 25 in here to give me the perfect square trinomial, yes? But anything I do to one side, I have to do to the other. So we need to know what this value is that we're actually adding into the equation. to the one side to make it a perfect square trinomial. Now, we can rewrite it as our set of parentheses squared. We'll have x. And again, what's inside the parentheses is what's going to go in there. So it's going to be our 5 is equal to, is negative 7 plus 25 is going to be 18. Well, now we have a set of parentheses squared equals a number. So we can square root both sides. And here the square root and square would cancel, telling me x minus 5 is equal to plus or minus 3 square root of 2. Well, we also found the square root of 18 not a few minutes ago. For one of the first problems, it was square root of negative 18. But last but not least, we need to which tells us x is equal to 5 plus or minus 3 square root of 2. Because we have the square root of 2, that irrational number, we can't actually combine these two. So that's our answer. And that there is completing the square. That's our first method that works for all the problems. It's not too overly complicated as long as we have all the steps there and followed in the correct order. It does get a little tricky when a is not 1, as we start dealing with some fractions. But on a whole, it's not too bad. Now this here, 3 and 5 are going to be the ones that we're solving. The left side, the quadratic side, is already a perfect square trinomial. So what you can do is factor that. You can do 2 sets of parentheses squared. Or 2 sets of parentheses, not squared, just 2 sets of parentheses, then make it into one that's squared, square root both sides, and solve for those two. 11 through 18. So you're finding the value of c, b over 2 squared, and then finding the set of parentheses squared for those there. And that's it.